Hello everyone, and welcome back to James's Industrial Assessment Center channel, where you can learn all about IIAC stuff. Make sure to smash that like button and get all your friends to subscribe for your amazing IIAC daily content needs. Great. Well, this is kind of going to be a boring video, but we're going to talk a little bit about a really important resource that we have recently found that can help a lot with costing and general AR development. So it's a great resource. We'll just go ahead and start talking about it. So first of all, how to find it, just log into your IAC box page, go to Reference Files, Internal Resources, and Costing Resources. This isn't just a costing resource, but it's in this folder for now, so just FYI. Go ahead and download it and open it in your PDF viewer of choice. And so here we go. It's called the Focus on Energy Technical Reference Manual. And what this basically is a giant list of ARs and useful info about them. And that useful info includes some costing info, some basic AR development stuff, some simple calculations, a list of assumptions, all this kind of stuff. It's really great. So some background on this document. It was put together by the Public Service Commission of Wisconsin. So everything doesn't directly apply to us because this was made in Wisconsin and we're in Utah, and there's some slight differences between some things which we'll talk about. But this is absolutely one of the best places you can start, especially if starting on a new AR, or if you're new or you just kind of need an idea or to spot check yourself or whatever. This is a great place to start, and we'll talk about why a little bit more. So this is a living document. It's updated twice per year. This is the 2019 most recent version. So if we do use this over the years, we will have to update it. So that's just something to be aware of. So I'm just going to go dive in and show you kind of how to use this manual. So we'll talk a little bit about first this executive summary. This is a really great place to come if you have questions on what some of the nomenclature in this document is. So you're going to see deemed savings, savings algorithms, and then in each section there's kind of a template that each AR is presented in the same way. If you have a question on what one of those things mean, come down here to this measure detail structure. And you can see, there's a table, you can see some of the definitions right here. We'll talk about this a little bit. And then, description of baseline condition, efficient condition, you can just see what all of these different things that we will see mean here. So this is going to be a good reference. So let's go back up. This table of contents is really great. So you have these different categories of ARs. So agriculture, boilers, compressed air, lighting, there's all these different categories, and then within those there's actually a list of ARs. So let's just say we're looking at an HVAC AR, and we'll say we're looking at these ECM HVAC fan motors. So just click it and it'll bring you to this, down to this page. And so here's the AR title, which is pretty obvious, and then there's this table, and then lots of, there's a few paragraphs, some simple calculations, some assumptions, and then some references and sources down here. So we're just going to go through as if we're using this document to help us with this AR, and we can kind of see how useful it is here. So first of all, this Measure Master ID, it doesn't really apply to us because these are local to Wisconsin, and this is more, their measure is kind of our AR, but they are thinking more in terms of like incentives and things like that. So that's what the Measure Master ID is. Don't worry about it for now. It's not important to us. Measure unit, that's important. So sometimes this will be per horsepower, sometimes it'll be per unit, sometimes it'll be per system. just make sure you pay attention to what that unit actually is, because that's going to be important as we go down and look at the costs and how savings are calculated, etc. Measure type, so this one's actually important, and we're going to go back and look at, we're not sure what that is, so we're going to go back here to the top, and we're going to go to this executive summary, and we're going to find where it says measure right here. This is what we're looking for. So the measure types, there's 3 different types. So this is going to be important. We'll just talk a little bit about what each of these measure types are. So this prescriptive measure, these measures have a specific deemed savings value that can be applied to each project within a given sector where the measure is used. So the bottom line is prescriptive measures are going to be deemed savings and deemed costs kind of things. So that means that these are done often enough that they can be generally applied to a wide variety of ARs that are similar to this. So if you have this exact AR, then you can likely use this kind of measure, this prescriptive measure, to spot check yourself. Your savings should be in the ballpark because, again, these are deemed savings, and these are widely applicable. Custom measures are measures where their ARs where they vary hugely in both their costs, their implementation, their savings. These you can't really use default values or whatever you want to call them. You can't come here and say, oh, this AR should cost X amount of money. These are just too custom and too complex, and they're different for each application. And then hybrid is kind of somewhere in between, but these are treated as custom measures. So they might have a little bit more applicability to a wide variety of ARs, but so this is important to understand, because if it's prescriptive, you should be somewhere in the ballpark, or you can use that as a starting place or whatever. If it's custom or hybrid, I would not trust it, and you will need to do your own work. So anyway, that's what that measure type is. So this is prescriptive, so we can use this. We'll talk a little bit about how we can use that. Group, HVAC, category, motors and drives, sectors, these are pretty self-explanatory. Sectors, some ARs apply differently depending on which sector you're in. So let's just say you have a boiler. Well, that can be a residential boiler or an industrial boiler or a commercial boiler. So some of these will vary based on what sector you're in, and there's some good info on a per basis sector for each AR. Then the rest of this stuff, annual energy savings, peak demand reduction, etc. These are all pretty self-explanatory, and we'll talk more about them once you get down there. Incremental cost is another big one. So this is going to be $1 per unit. And again, if it's prescriptive, then we can say that our implementation cost should be somewhere around here. So it's always going to be $1 per unit. Usually it matches up with this measure unit up here per horsepower. In this case it doesn't, it's per motor, and that will always specify. If it does not specify, then it's going to be per unit, whatever it is up here. So this incremental cost means that if you have 4 motors that you need to replace with these ECM motors, you're going to basically just take $120 and multiply it by 4. So this incremental cost does not always include or ever include labor and installation. You need to do your own research and get your own quotes in order to have an accurate estimation on your costs. All this incremental cost is saying is that generally these motors cost about $120 a piece. So if you need 4 motors, well then just multiply that number by 4, and that's what your motors should cost. Obviously that will vary widely based on your manufacturer and your quality and whatnot, but that's just kind of a good benchmarking for parts only. Again, you need to think about your own auxiliary equipment, freight, all that kind of stuff. So good starting spot, but please don't put too much weight on this number. So this measure description is basically just a description of what this AR is. So we can just go ahead and read it. This measure is for the installation of an electronically commutated motor, or ECM motor, with less than 1 horsepower on air handling equipment such as exhaust fans, fan coil units, VAV boxes, and cabinet heaters. So something that helps to understand this measure description a little better are these two next descriptions, the baseline condition and the efficient condition. The baseline condition is basically what you would look for when you're going to look for an opportunity for this AR. So you'll walk into an assessment and you will see this baseline condition. So for example, the baseline condition for this AR is going to be existing motors that are either SP or PSC motors that are less than 1 horsepower. So you'll walk into a refrigeration unit, for example, you'll look up on the ceiling and you'll see 2 sets of 4 motors, of 4 little fans, each with a PSC motor on it. So that's the baseline condition, and that tells you that you have an opportunity. That opportunity is going to be this efficient condition. So the efficient condition is an ECM that is equivalent to these motors being replaced. And basically the difference in these is these ECM motors are much more efficient than either of these 2 motors. And while they're very small motors, obviously they're less than 1 horsepower, they have very high run hours. So refrigeration units and that kind of thing, they will have very high run hours. And so those small differences in efficiency do make a big difference. One thing I wanted to point out here while I'm on that note is there's this hours of use by fan type and sector, which can be helpful in determining kind of your hours of use. So if it's 24/7, then it's going to be 8760. And then if it's a ventilation fan, depending on your sector, so these are kind of just good ideas and a good assumption if you don't know what kind of hours these fans are going to be running. Obviously you want to talk to your assessment contact and see if you can figure that out, what's specific to that facility. But if you can't, this might be a good place to come for assumptions. And if you want to know where these came from, just check out these footnotes, because there's a lot of research that went behind these numbers. So go ahead and check out those footnotes for some good estimates. Anyway, so hopefully that makes sense. Measure description is just a basic description of the AR. Baseline is what you will look for or see on an assessment. An efficient condition is what you will recommend. This annual energy savings algorithm is basically some simple equations that you can use, and this is a great place to start when you want to know where your savings are coming from. What's your actual savings mechanic? So you can come down here and see, your basic kWh saved equals, and then this equation, you can see all of your variables here. This is obviously going to be different for each AR. So great place to start. I would guess that these are not going to be as engineering as intensive as we want sometimes. So don't just come to this and automatically assume, oh, this is all I have to do. Please, again, do your own research. Don't put too much faith in this document. This is a great place to start and to give you an idea, but please develop and do your own research. Already talked about that. Summer coincident peak savings algorithm. So this is basically demand savings, and obviously that may apply to your AR, but one thing you have to be aware of when it comes to this document is this is how they are calculated in Wisconsin. So we're going to go back again to the executive summary and look right here, this summer coincident peak savings algorithm. This is under the assumption that peak electric demand in Wisconsin occurs weekday afternoons from 1 p.m. to 4 p.m. in the months of June, July, and August. That is not necessarily true in Utah. So that is one thing you have to be aware of. While you might be able to use this equation or something, you must be aware that this whole section is based off of that assumption. So don't take that don't just transfer that directly to your AR. You need to make sure that it applies to your AR. Okay, life cycle stuff, we don't often do this, but if you're interested in the life cycle or effective useful life, go ahead and come here. There's some good info on it. So these deemed savings are different than the savings algorithm that we saw above. So basically with the algorithm, you are calculating the savings for the specific application. Here we're going to see some deemed savings. So let's say that there's a lot of research behind this, and people who know what they're talking about have done this so many times, and they've done a lot of research that they've come to the conclusion that under these conditions, this is what we could expect to see as far as savings go. So this demand reduction by fan type, our baseline horsepower and our proposed horsepower. These are going to be the same in this case because, again, all we're changing from PSC to ECM motors is the efficiency. So they're both going to be 1 horsepower. On a different AR, that might be different. But so there's no reduction in horsepower here. However, there is an increase in efficiency. So we will see some demand reduction. If you see heating fans versus cooling fans versus occupancy fans versus 24/7, we're obviously going to see different numbers on these based off of how they operate. Heating fans hopefully will not be operating during peak hours of the day, but cooling fans probably will. So, there's things that you have to look for there. Just make sure you're thinking about this, but again, this is a good place to benchmark yourself. Annual energy savings by fan type, same kind of thing. We're going to see different kWh savings based off of the sector and what type of fan it is. And that, again, that's mostly based off of what hours during the day and during the year that's going to be running. So baseline assumptions, baseline, this is a great place to check yourself or to get an idea of what your savings could be. And this is per 1 horsepower motor. So if you have 4 of these motors, you can scale that accordingly. Life cycle, same thing as above. We don't do a lot with that, but good info on it if you need. So I have found these assumptions to be quite helpful on a lot of ARs, especially because that's a big part of our job is making assumptions. Obviously, these are going to differ based on where the facility is, what kind of, every AR is different. But these are often a good place to come look for assumptions. For example, if you don't know anything about SP or PSC motors, well, you can come here and say, and read right here, oh, they're on average 30% efficient, 42.5% efficient, and these will often have better sources that are listed down here. So go ahead, take a look at these assumptions on your AR, and they might just give you some good places to start. So sources, this is a very, very valuable thing that we have on this document. So if we go up here, let's use this incremental cost as an example. So we want to know where this came from. Does this $120 include installation? Does it, what does that include? Where did it come from? Well, we can see that's at footnote 3. So let's go down and we can look at the exact source where they pulled this info from, and they provide a link. Great, let's go look at it. So then you can scroll through this. I'm not actually going to do it right now, but this is a great place where you can come and find why and where they got the information that they listed. So this can get you started, and this could get you potentially to some vendors. It could get you to a lot of research reports, but this is some good stuff to use. And while I don't know if I would recommend referencing this document specifically, I don't see a problem with citing and citing a lot of these sources directly. So again, you will use your own judgment based on how useful you find these. So hopefully that is a decent tutorial and just kind of shows you how to use this document. It can be pretty useful. Again, I want to emphasize, please don't just take this and apply it directly to your AR. This is a great starting place. It can get you some very useful sources. It can give you an idea. It can benchmark you, but don't just take this and apply it directly to your AR, because it may be very, very different. Whether it's because of location, Utah versus Wisconsin, or there's a lack of engineering intensive calculations, etc. So hopefully that was okay. Please, if you have any questions, feel free to email me. I'm available most of the time, or just contact me. Hopefully we can use this and it can become a valuable resource for us. So thanks, guys. Have a good one.